All right, guys, welcome back. Skills practice, chapter 4, section 4. All right. All right, guys, so this section, we were getting our sequence and graphing it. And we realized that arithmetic sequences are linear. They're discrete, but they're linear. And geometric sequences are exponential. We explore that a bit. All right, let's get started. Quickly, I want to make a really short tutorial for you. All right, put your name on there, blah, blah, blah. All right, looking at this. Number one, even though it's the example, we should always try that out. Compare the table, blah, blah, to the given sequence and graph each sequence on the coordinate plane. All right, so the first thing you want to do is explore your function, your exponential or arithmetic or linear. What is it? It's a lot of words that you're learning here. A lot of you saw that if it's a plus, then it's arithmetic. Okay, arithmetic. Let's put AR for arithmetic, and the 3 here. That represented our common difference, D for difference. How much is it increasing by? And then the first term was 15. So you can see that. That is the first term. So you're going to start at 15 and then go up from there by 3. So they did this for you. But here's the idea. 27, and so on and so on. And then you're going to graph this on a coordinate plane, and n will be your independent variable, that's your x, and the value will be the y. See, this is the value. So this, the key, they broke these up, they graphed them by 5s on the y. Okay, they're 5, 10, 50, 20, and 1, 2, 3, 4, 5 on the x. And probably the reason they saw that these numbers ended up at 40. So basically, the first point is 1, 15, and then up 3 every single one. Notice how it's not connected. It's not a line. Okay, it's not that. See if I can undo that. No, I guess not. All right, let's do one together down here. All right, this one is geometric, and you can tell by a couple of different ways. One way you can tell is by, this is multiplication right there. So that makes it geometric. This is the first term, 3. That's the first term. I'm going to call it FT, first term. And the multiplier, how much is it multiplying by, is this guy right there. That is the multiplier. It's called the ratio, common ratio. So that means you get the first term and then you multiply it by 2. So the next one would be 6. So it'd be 3 times 2, 6. And the next one would be 6 times 2, 12. And obviously, you don't have to write all these down, but it's important to understand the terms. 12 times 2, 24. So basically, you multiply the last one, 48, and so on. Do the rest of those. And then you want to graph this. Now, the numbers are getting really large. How can we do this? Let's see, look at this. There's 10 grids. There's 10 of these grids there. Okay, there's 10 of these. And the numbers, let's see how big they get. Double that, 96. Double that, 192. Double that, 418, 384. Double that, 8, 16, 6, 7. I mean, let me know if I make any mistakes. And double it. So they go by a lot. We're probably not going to be able to graph the big numbers, but let's go by tens, I think would be an idea. So go ahead and let me zoom in here. Whoops. Okay. Whoops. Bear with me. I'm trying to find my erasing tool. This one, no. Yikes. Lost it. All right. I'll use red. So this will be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, the first one is 1, 3. So keeping with the red, so it's 1 to the right, up 3. Just give or take right there. The second one's 2, 6. Something like that. 3, 12. 4, 24. I'm kind of estimating here. 48. 5 is 48. See how it's going up really fast. 6, 96. 90, well, that thing went up really fast. This might be the last one we get to do. All right, so there is our exponential geometric. It's called geometric. So we're describing the terms. Now you don't want to connect the dots, but you can see how they would go straight up like that. But don't connect them, just pure dots. It is discrete. Okay, let's look ahead and see if you can do this on your own. All right, here's the next page. This one got some negatives, so I'm gonna get you started just to make sure you understand. This is your first term, and then this is arithmetic. We are actually subtract. Whoa, let me see this. Is that a plus? Yeah. So it's a -8. Okay, so it's going to be going down 8. So the second one is going to go down 8, so that's going to be 42. So -8. This is the number that tells you how much is increasing. So then the next one would be -8 of 42, which is, I forgot, so you figure that out. All right. So finish the rest of this and then graph it. Starts at 50 and goes down by 8s. So perhaps you want to break these up into 5s maybe. You think about it. 5, no, that was only going to give us, that'll give us to 50, right? 10, 20, I'm skipping one, 30, 40, 50, and these are 45, 35, 25. So the first one would be 150, so that's right there. Go ahead and do those. Pause it right now while you do that. I'm going to look ahead. All right, go ahead and pause it and continue once you're ready to do 4. All right, guys, here's 4. 4 is geometric. The first term is that one. That's where it starts off. And this one, we are actually going to multiply by -2. So this is the ratio. The ratio, should I write the whole thing out? Equals -2. So the idea here is that you're going to get the first term, and then you're going to multiply it by -2. That'll give you -6, all right? And then do the same thing for the next one, and that'll give you +12. So you switched from positive to negative. Why don't I do this, just so you can see this clearly? The red ones, I'm going to make the negative numbers, and then the positives, I'll make them blue, just so you can see that really clearly. Erasing tool, where are you? I don't see you. Why don't I have an erasing tool? Darn it. Okay, well, I said blue for positive, and then we're going to multiply that by -2. That's a multiply. Just I shouldn't do that. I should not put an X. Anyway, so the next number will be -6, and then times that by -2, and you're going to have 12. And then times that by -2, and you have -24. What I wanted you to notice on this one, it goes from blue to red to blue to red, which is positive, negative, positive, negative. So then your numbers are going to be switching back and forth from positive to negative whenever you multiply by a negative. So when you graph this, it's going to be flipping from positive to negative. Perhaps you should have your axis in the middle somewhere. Like this one be your x-axis. Okay, that could be your x right there, and then your y. You know, since it's starting at a positive number, maybe this guy over here. What the heck? Can I move this? Yeah, look at that. That'll be the y. So the first term was 1, 3. So let's say right there, that's 1, 3. If these are by 5s, remember? And this is -5, -10, -15, -20, -25. So that's the first one. The second one's 2, -6. So 2, -6, right there maybe, somewhere. The next one is 3, 12, 3, and then up here. So it's going to go up and down, like it's going to go back and forth, and it looks like they're getting farther apart, because the fourth one is -24. So it'd be 1, 2, 3, 4, and then down 24. So there's 20, like over here. Okay, and then the next one will be 48 and such. That's that. All right, pause it here while you finish that, and I'll look ahead on the next one, and I think that'll be all for my help for today. Oh, my grid didn't stay. Sorry about that. I think I had it like that. All right, I think you can do 5 on your own. Place attention to if it's arithmetic, what's the first number, and how much it's multiplying by. All right, guys, so go ahead and do that one on your own. Try to figure out what is the best way to break up your graph so that it gets the most points possible on there. And let's look at number 6. 6 starts at -1, multiplied by 2. I think you can do that one. Same idea. I think this was going to be all negatives because the multiplier is by 2. See? It's going to be multiplying by 2. Well, look at that. Oh, wow. Hang on, guys. Can you guys see that? There's a lot of little dots coming up. Laser pointers. All right, let me look at the last page. Same idea, and let's here, number 8. So go ahead and pause. I'm going to stop right here, but this is huge numbers. Let's look at this. You might want to use your calculator. It might bring those numbers small. It looks like the first term is 32,000. So you could put 32, 1, 2, 3. That's your first thing. And then the multiplier is half. So that's going to bring that, the ratio is half. Okay? So the exponent is 2 for n minus 1. So basically, I'm going to guide you through this one, and then you can finish the rest. All right, so you replace number 2 here. So it'll be 2 minus 1 is 1. So this will become 1 right there, right? You agree with that? Then, okay, oh, there we go. Finally got my eraser. So that's 1. So then it's going to be half, because 0.5 to the first power is still 0.5, which really means half. What is half of 32,000? Well, half of 32 is 16, so I'm going to guess it's 16,000. So it looks like it's getting half of the number. The multiplier is half, so just get half of that, 8,000, and so forth. And then when you graph it, make sure you put your scale on your grid to figure out what is a good way to get 32,000 as your highest and coming down. It should look something like this, okay, with dots, of course. Okay. It looks like I don't have an undo button. I'm sorry. All right, so it's going to be dots with a reverse exponential negative. All right, guys, I would like you to post a comment on here about what your understanding is of graphing arithmetic and geometric sequences. When you use your vocabulary, your academic language with the words discrete, racial, first term, and so on like that. All right, 10 points for each. Make sure that you post it on Friday's homework if you did not. Okay, that's all, guys. Bye-bye.